All right, so let's continue with more practice graphing rational functions. So first, find the x-intercepts. I'm going to set the numerator equal to 0. So x equals -3. So I have the point -3, 0 as an x-intercept. Okay, y-intercept. When I set each of my x's to 0, I get -3/4. 3 over -4. Okay. Oh, sorry. Should have started with the domain. Denominator cannot equal 0. So I have x squared cannot equal 4. So that gives me two restricted values of both positive and -2. So when I go to look at my limits, I have the limit as x approaches +2. If I plug that into my function, that gives, I'm just going to put y here instead of writing the function. That gives me 5 over 0. So I have a vertical asymptote there. If I attempt to take the limit as x approaches -2, then I get 1 over 0. So it verifies that those two domain restrictions are both going to be vertical asymptotes on the graph. X equals -2. All right. Horizontal asymptote, we'll talk about the limit as x approaches infinity. So now at infinity, we have to check top heavy, bottom heavy equal. So I compare highest exponent in the numerator with highest exponent in the denominator. It's a bottom heavy function, so my limit is 0, and therefore I have a horizontal asymptote at y is equal to 0. Okay, so let's put all the stuff in. X-axis is a horizontal asymptote. Vertical asymptotes at both 2 and -2. I have an x-intercept at -3, 0, and I have a y-intercept at 0, -3/4. Okay, so now let's check out the sign analysis. I have an x-intercept at -3. I have a vertical asymptote at +2, and then I have a vertical asymptote. I have vertical asymptotes at -2 and +2. So now I have to test all of these values. So if I plug in a value less than -3, -4 would give me a negative numerator, but a positive denominator, therefore making the interval negative. If I plug in -2.5, then I would get a positive numerator and a positive denominator, therefore making my graph above the x-axis. Between -2 and 2, I'm going to test 0. 0 would give me a positive number over a negative number, therefore making my interval negative. And bigger than 2, if I were to test 3, I get a positive over a positive, therefore making my graph above the x-axis on the last interval. Okay, so now let's just see how this sort of plays out. I have to be below the x-axis to the left of -3. Then at -3, I'm going to cross the x-axis, and then I have to end up being positive, so above. So here I am below the x-axis. I cross over at my x-intercept, and then I'm going to continue to hug that vertical asymptote. Now we have something different happening here. So my horizontal asymptote, I have an x-intercept on that. So how can that happen if we've said that asymptotes are things that graphs come really close to approaching but never actually do? What you need to understand is that to find a horizontal asymptote, we're looking at infinity. All right, we're looking at the end behavior. So as x gets infinitely smaller, the graph is getting closer and closer to 0. So the fact that we have a point where I'm going to cross over that line, that's okay. It's just the end behavior. As the x values get smaller and smaller and smaller, my y values will trend, will hug that line y is equal to 0. All right. Now, between -2 and 2, I have to strictly be below the x-axis. So I have two vertical asymptotes there, and I have my y-intercept. So I have to hug my asymptote. I got to get through my y-intercept, and then I have to hug the asymptote on the way down. So it sort of looks like a downward-facing parabola in that region. Then lastly, bigger than 2, my graph has to strictly be above the x-axis. I have a vertical asymptote at 2, and I'm going to hug my horizontal asymptote at y is equal to 0. So there's 3 different quadrants, I guess sections, that have a graph for this rational function. All right, now the remaining examples are all when your function is bottom heavy. Okay, so just what's the significance of that? If you take the limit as x approaches infinity of a bottom heavy function, the limit is always going to be 0. So all these functions that are bottom heavy, we automatically know that they have horizontal asymptotes at y is equal to 0. Okay, so the x-axis will be a horizontal asymptote. All right, so let's start with the domain. Denominator cannot equal 0. X squared cannot equal 1. So I have 2 restrictions at plus and minus 1. X-intercept, let's set our numerator equal to 0. So 3, 0 is an x-intercept. Y-intercept, if I replace my x's with 0, I get negative 3 over negative 1. So I have a y-intercept at 0, 3. When I look at the limit as x approaches 1 of my function, I get negative 2 over 0. So that verifies x equals 1 is a vertical asymptote. When I look at the limit as x approaches negative 1 of my function, I get negative 4 over 0, therefore giving me another vertical asymptote at x is equal to negative 1. And then we already know that there's a horizontal asymptote at y is equal to 0. So we said that because it's a bottom-heavy function. Horizontal, vertical, and another one. 0, 3 is a y-intercept. 3, 0 is an x-intercept. So it's looking probably that we're going to cross over that horizontal asymptote right there, definitely at 3 and possibly somewhere else. Now our sign analysis. Asymptote at negative 1, positive 1, intercept at 3. All right, so if I plug in negative 2, that'll give me a negative numerator and a positive denominator, therefore making the interval negative. If I test x is equal to 0, I get a negative over a negative, so I'm going to be above the x-axis there. When x is equal to 2, negative over a positive denominator, so I'm back below the x-axis on that region. And then any number bigger than 3 is going to be a positive over a positive. I'm sorry that the computer keeps switching screens. Okay, so less than negative 1, I'm strictly below the x-axis. So I'm going to hug my asymptote, my horizontal asymptote, and then I trace along the vertical asymptote. So there's region 1. Now for here, between negative 1 and 1, I strictly have to be above the x-axis. So in order to be above the x-axis and still go through my y-intercept, it's going to look like an upward-facing parabola. Okay? Now here, between 1 and 3, I start out below the x-axis, which makes sense because there's my vertical asymptote. I'm going to cross over my x-intercept, and then I'm going to end up above the x-axis, but I'm going to hug my horizontal asymptote at 0. So I'm below the x-axis to above the x-axis. But I know that I can't just let this go on forever. I can't let the arrow go up. The arrow has to approach 0 because that's what my horizontal asymptote is. Let's trace that again. And these are just simple sketches, right? I just need you to have that general behavior correct. Okay. So next one, x-intercept. Set the numerator equal to 0, so the origin will be an x-intercept. Y-intercept, 0 over anything is also 0, so my x and my y-intercept are at the same point. I did it again. We've seen this before. X can't be plus or minus 2. So for my vertical asymptotes, limit as x approaches positive 2 of my function. That would give me 2 over 0. So there's a vertical asymptote at x is equal to 2. If I look at the limit as x approaches negative 2 of my function, I get negative 2 over 0. So I have another vertical asymptote. We said it's bottom heavy, so we know that there's a horizontal asymptote at the x-axis. Horizontal. To vertical. Whoop. X-intercept and y-intercept at 0, 0. All right, so let's do our sign analysis. Asymptote at negative 2, x-intercept at 0, asymptote at positive 2. All right, if x equals negative 3, negative numerator over positive denominator, therefore making my graph below the x-axis. If I plug in negative 1, negative numerator, negative denominator, therefore makes my graph above the x-axis. X is equal to positive 1. I get a positive over a negative denominator, so I'm back below the x-axis. And then any number bigger than 2 would be a positive over a positive. Okay, so now this one's going to look a little different between our vertical asymptotes, so don't just go sketching away. Below the x-axis to the left of negative 2. Okay, that shape, we've really done that shape a lot. Between negative 2 and 0, you have to be above the x-axis, but between 0 and 2, you have to be below the x-axis. So between the asymptotes, instead of this looking parabolic, it's actually going to look like a reflection of x cubed. So I'm going to hug the asymptote here. I'm going to go through my x and y intercept, and then I'm going to hug the asymptote at positive 2. Okay, so it can't be a parabola because I have to switch over the x-axis. The sign analysis told us switch from above to below the x-axis at 0. Now my last interval, x is bigger than 2, so I'm strictly above the x-axis. All my y values are positive, and I hug that intercept, that asymptote rather. All right, last example. This one looks a little different. Our domain, I'm going to go right to factoring, factors of 6 that add to 5, and this is the first example where we're looking at that factoring technique. So my restrictions, x can't equal negative 3 or negative 2. X-intercept, set the numerator equal to 0, so the origin is an x-intercept. My y-intercept, it'll be the same. It'll be at the origin as well. Limit as x approaches negative 3 of my function, that would give me negative 3 over 0. So there's one vertical asymptote. Limit as x approaches negative 2 of my function, that would give me negative 2 over 0. So there's another vertical asymptote. These are really close. We know we have a horizontal asymptote at y is equal to 0 because it's a bottom heavy function. So negative 3, negative 2, x and y intercept at 0, 0. Asymptote at negative 3, at negative 2, intercept at 0. So those are the values that go on my sign analysis. In the interest of time, I'm going to ask you to finish this. So complete the sign analysis. And attempt to sketch. Okay? So do your best. Once you have it in there, you can always use Desmos or a graphing calculator to see if you did it correctly. All right? But have those two parts completed for the next time we see each other.